Hi, welcome to another exciting episode of Mr. Shalednik's Quarantine Geometry videos. Just got done organizing my sock drawer alphabetically, and then when I was done with that, I built this police car out of Legos because I literally have nothing else better to do. Well, except for geometry, that is. Today, I'd like to go over lesson 6.2 with you. So I'm going to do that. I believe, let me see if I can get it up here. I believe it looks like this. So here we go. We're going to start with this warm-up. So these are isosceles triangles in the warm-up. And maybe you learned from a previous course, I'm hoping you can remember, the triangles add up to 180 degrees. Now, since these are isosceles triangles, remember isosceles means that two of the sides are equal in length. So those tick marks right here in the first warm-up question show that those two sides of the triangle are equal. Well, if those two sides in the triangle are equal, then these base angles are also equal. So angle A is going to be equal to angle B. It's going to be 69 degrees. And B, we're going to figure out because the angles in a triangle add up to 180. So we're just going to take 69 plus 69, doing the best I can to write on my laptop screen. So bear with me a little bit. Carry the 1, that's going to be 138. If we take 180 minus 138, you will get 42. So angle B is 42 degrees. Okay. Angle T, okay, in the next one, angle T, again, this is an isosceles triangle. So if these two sides are equal, then these base angles are equal. So to figure out angle T and V, which are going to be the same number because it's isosceles, you're going to take 180 minus 112, and that's going to be 68. But that's both of the angles added together, because remember, all three angles add up to 180. So that means that each angle would be half of 68, which is 34. So 34 for each angle. All right, I'm going to move along now. And 6.2, isosceles triangles. I always wanted to name my, a kid. If I had a daughter, I would name her Celise, so that every day I could say, I saw Celise. I'm sorry, that's a dumb joke. Okay, example 1. In triangle XYZ, XY equals 6, YZ equals 10, and ZX equals 7. List the angles of the triangle in order from least to greatest. Pause the video right here because we need to discuss what is something that you should do to make this problem easier on yourself. If you pause the video, hopefully you said, you should draw a picture. That's what we're going to do. So it's a triangle, and it is triangle X, Y, Z. Bear with me. I'm doing the best I can on this laptop screen. X, Y, Z. So XY equals 6. YZ equals 10, and ZX equals 7. List the angles in order from least to greatest. So let's think about this a second. I'm going to go up here where I have some blank space. Let's think about this. So if I just think about what happens, let's say you have two triangles here. Let's say you've got, I don't know if I'm going to do my best to explain this. I don't know how good I'm going to be, but I'll do my best here. I feel like if I was in person, I'd be a little better at this. But let's say you have this triangle, or you know what? Better yet, let me pause the video and go get a prop here. I think that might help actually. Hold on. Let me see how I can pause this. How do you do this? Hold on. I'm sorry. Meeting controls. I just want to, you know what? Never mind. Let's just say you have a triangle, one with, and let's say this, two of the sides have a certain length. Okay, and you have another triangle where two of the sides have the same length. Okay, but this angle in this triangle is bigger than this angle in this triangle. I want you to observe here, this is the best I can do without a prop. I want you to observe that this side in this triangle is obviously longer than the opposite side in this triangle. And actually, I am going to get a prop. Hold on, I'll be right back. Okay, look. I've got these scissors right here, okay? I've got these scissors. And let's pretend these are the sides in a triangle. See how, okay, if I only have the scissors open a little bit, this distance is not very far. But if I open them more, then this distance grows. See that? See how long it is now? So it follows that the bigger this angle is, the bigger this side opposite the angle is. Just like in this picture here, the bigger this angle is here, the bigger this side opposite the angle is. So if we apply that principle to this problem, it follows that the biggest angle is across from the biggest side, and the smallest angle is going to be across from the smallest side. So which side is smallest out of these three? It's 6. So if we go opposite the 6, the smallest angle is going to be angle Z, okay? The medium side here is 7. If we go opposite the 7, that means the mediumest angle, the medium angle in size, that is going to be angle Y. And the biggest side is 10, and therefore the biggest angle will be angle X, okay? It goes the other way too, which we'll see in this next example. So in triangle ABC, measure of angle A equals 85. Oh, let me draw this while we're just at it. So here's A, B, and C. Measure of angle A equals 85. Measure of angle B equals 45. And the measure of angle C equals 50. List the segments of the triangle in order from least to greatest. That looks like 56 a little bit. There we go. That doesn't look any better, but oh well. So the littlest angle here is 45. If we go opposite the littlest angle, that means the littlest side has to be AC. The medium angle is 50. So if we go across from the 50, the medium side is AB. The largest angle is 85. So if we go across from the largest angle, the largest side will be BC. Man, we're just killing it today. We're just, for day one of virtual, we couldn't be doing any better. Holy cow. It says in triangle XYZ, an exterior angle to X has a measure of 115. I'm gonna draw this right off the bat. XYZ. It's always a good idea to draw the picture before you try and do anything else. So the measure exterior to X. So remember, an exterior angle, I taught that this lesson virtually about exterior angles, but exterior angles are when you make one of the sides longer. This angle out here is 115. This angle right here. An exterior angle to Z has a measure of 142. Okay. And which side of XYZ is the longest? So we're going to have to solve for the interior angles and then apply the same principles that we always have been applying throughout the whole lesson. There's Logan. He's getting excited about this. Okay, so if we take, see, this is a straight line. So how are we going to find the interior angles? Hopefully you're thinking, oh, straight lines are 180. So take 180 and subtract 115. And that means that this angle has to be 65, right in there. Okay. And then similarly, we're going to take 180 minus 142. And that means that this angle here has to be 38. Okay. So triangles add up to, the interior angles add up to 180. So if we do 65 plus 65 plus 38, that brings us to a total of 103, I believe. Yeah, that's what it would be. 103. All three angles add up to 180. So take, I'm going to do this right here where it's in space. So take 180 minus 103. That means that the remaining angle must be a 77-degree angle. Okay? So now we just go, it just says which side is the longest. That's all it wants. It doesn't want them in order from least to greatest. It just says which side is the longest. Well, the biggest angle is 77. Go across from the 77. That means XZ. XZ is the longest side. We've got one more. It says in triangle PQR, the measure of angle P equals 72. Again, I'm going to draw a picture. PQR. This is 72 up here. And the measure of angle, it doesn't say exterior angle this time, so we're assuming it's the interior angle. Measure of angle R equals 53. And what's the shortest side? Okay, so again, the angles in a triangle add up to 180. So we're going to do 180 minus whatever these two add up to. Oh, Logan's just loving this lesson right now, isn't he? Yeah, okay. Anyway, so 72 plus 53. Logan, I'm almost done here. I'm almost done, buddy. So this is 125. So take 180 minus 125. The remaining angle must be a 55-degree angle. Okay. So the shortest side will be across from the littlest angle. That's 53. That means the shortest side must be EQ. Hope you enjoyed the video. I got to take care of Logan. He is done with math. Yes, there we go.